Number 8. Number 8 asks us to solve for the limit of this. So, when we look at this, if we just plug in 0, just in case, the bottom becomes 0 and top becomes, when we plug in 0 here, it will be same value and becomes 0. So it will be 0 over 0. And now, because we have proved that it is 0 over 0, because 0, 0, minus, minus, we can use a L'Hopital's rule. So let's differentiate bottom and top and plug in 0 again. So when we differentiate this, this will become, first this will cancel out and this will become 1. So let's ignore this 2 and solve 8 1/2 plus h 8. And when we differentiate this, the top number goes to here, 64, and because there's no chain rule, there's nothing to do with chain rule because there's no actual constant in front of h, so we can just go with 1/2 plus h to the 7th. And now this will become limit h as h upper 0, 64, 1/2 plus h to the 7th. And for you to not get confused, I will put over 1 because over 1. Now let's try to plug in 0 here. When we plug 0 here, this will become 64 1/2 to the 7th. And what's 2 times, annoying I know, 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7. This will become 4, that will become 4, that will become 4. This whole thing will become 4, 16, 64, 128. Yay! So it will be 64 times 1 to 128. Wow, how kind is college board? We can cross it out and make it to 1/2. And let's see. So for number 8, 1/2 is choice B. So the answer for number 6 is B. Number 7. Number 7 says, for what value of k will x plus k over x have the relative minimum at x equals to -2. So, relative minimum. So, we can say this is just a y function, y, and relative minimum we can get it from y prime x by setting equal to 0. And because it says relative maximum, excuse me. So, relative maximum will look like this, which will be positive here, negative here. For this problem, we don't actually need to know that, but I was just to make inference about this question. So let's start this. Because like I said, we need a y prime graph. Let's differentiate this. So if we differentiate 1, if x, it will be 1 plus, and if we differentiate this, it will become, because this is like 1, just think this as, I'll just draw it like that, as x minus 1, and if we differentiate that, it will be 1k x squared. Now, if we simplify it, it will be 1k x squared. And because x is -2, it's given, yes, it is given, we can just plug this number into there. So it will be 1 minus k over 4. Now, what do we have to do? This is our solve for function for y prime. And because we're solving for relative maximum, we have to make it to equal to 0. So then what will be k? What is 1 minus something equals 0? It will be 1. So how do we make this fraction as 1? We can just put k equal to 4. So the answer for this is 4. So the choice D will be the correct answer. Number 8. Number 8 says, if h of x equal to f squared x minus g squared x and g prime x is fx and f prime x is equal to negative gx, then what is h prime x? So, because it's asking for h prime x and they gave hx, we have to solve for h prime x. So let's just differentiate this. It'll become h prime x. If we differentiate this, this 2 will become to the front. Oh, sorry, if I'm going to say it, I forgot it. It'll become 2 f of x. And one thing you have to be careful is this. Because we're differentiating by h prime x, hx, this will follow it, h prime x. So same thing for this. If we were differentiating by hx, if it was h squared x, then we don't have to do this. Because we're differentiating by hx, which we want to know h prime x, we have to put this back. It'll be 2 g of x and g prime x. And now, let's plug in the given functions. So, it'll be 2 f of x, and now f prime x equals to negative gx, so negative gx minus 2, before that, I'll make sure to draw a line here. Okay. So, this is just like a line. So when you look at it, this is g prime x, and g prime x equals to f of x. So 2, I'll go with prime first. F of x, and now gx. Everything's done. We can just simplify this as h prime x is equal to negative 4 fx gx. This is really simple question, and the answer for this is choice C, which exactly says negative 4 f of x gx. Number 9. Number 9 says, the area of the enclosed region bounded by the polar graph of r equals to radical 3 plus cosine theta is given by the integral. And there's 5 choices A through E. And actually, for this answer, we don't have to solve through all steps. We can just have an integral equation, and that will be the answer as you look at the choice. So, this is a little simpler, and we have to use that equation of area because it says the area of the closed region. So, I'll write down the area, the function, AB, area equals to 1/2 r squared d theta. So you have to memorize this equation to solve this problem. So the r is given, so we can just plug in here, and it is for area. So let's work on this. Because this is constant, the 1/2, we can take this out, 1/2, and b will be 2 pi, and a will be 0. As you get the unit circle, 2 pi is here, and 0 is here. So full circle. And r squared, so it'll be radical 3 plus cosine theta squared d theta. Like this. And as you can see, there's 1/2. I want to cancel 1/2 because as you look at the option, you will see you might have to cancel 1/2. So by taking out 2 from both sides, as this is the property of integral, this is the basic property of integral, so because we took out 2, which is dividing by 2 from b and a, it will become pi and 0. And same thing, 3 plus cosine theta squared d theta. And because it's cancelled out, it's 1. And let's look at the options. So, first we have to look for pi and 0. So, for option pi 0, it has b and d. B and d has the pi and 0 for the functions. And now, let's look at this. Because this radical is, I'll write it slowly here, and I mean smaller. It'll be 1/2, and then it's squared. Do you get it? So this is radical, so it's 1/2, and parentheses 2. So this cancels out by the properties of exponential, and the inside function, the final answer will become pi 0, 3 pi cosine theta d theta. Like I said, for the options that had pi and 0 for B and A, that was B and D. And when you rush in the test, you can just see B and oh, I found the answer and check that. However, you have to look at this. There is a radical here and square here. So you can cancel out to like this to be 1. And that answer becomes D. So be sure to not rush yourself and be sure to not make any mistakes like this. So the final answer will be D, which is integral pi at 0 to pi 3 plus cosine theta d theta. Number 10. Number 10 asks us to solve for this integral. Oh, sorry, it will be dx. Never forget the x. So when you look at this, you might be confused. How can I start? Is this quotient rule? But how can I do quotient rule? Sorry, while it is integral. You have to think. When you see x squared plus 1 at the bottom, you will remember, oh, it's arctangent. But another problem or obstacle is in the way, which is x plus 2. So the way you do this is simplify this in a solvable way. So it'll be 1, 0, like that. So what I mean by solvable is try to make this equation as 1 over x squared plus 1. So you can right away think, oh, arctangent. So before that, I'll say, what is 1 plus 1 minus 1? It's 0, right? So because it's 0, it doesn't affect anything on the equation. So I'll add plus 1 and minus 1 here. So x squared plus 1 minus 1 over x squared plus 1. Even though you think it's weird, just keep following it. You will see. So, by doing this, because its denominator and the numerator has few different variables or numbers, we can divide by 1, 0, x squared plus 1, x squared plus 1, minus 1 over x squared plus 1. Do you get it? Like I said, in a more solvable or familiar way, we know 1 over x squared plus 1, right? So we can just write off going there with arctangent. And by looking at this, oh, same variables and same numbers. You can just go with 1 because it cancels out. So it'll become 1, 0, 1 minus that plus 1. Never forget dx. This is my mistake. Dx. And last step is to integrate this. So this will be 1, which is x, minus arctangent x, 1 and 0. As you can see, 0, x, when you plug 0 to x, x will be 0 obviously, and arctangent when you think 0, because sine is 0, it'll be always 0. Because tangent is sine over cosine, and when sine is 0, it will be always 0, because sine is numerator. So let's ignore 0 and think about 1. So when we plug in 1, it will be 1 minus 1 minus arctangent 1. And for arctangent 1, you can think like this. What does this equal 1? And you can think, what value of x can I divide by sine and cosine, sine over cosine, to make 1, which will become pi over 4. Because pi over 4, when you think unit circle, sine of pi over 4 is radical 2 over 2, and cosine of pi over 4 will be radical 2 over 2. And the tangent x will be 1, because sine over cosine, this same value will cancel out. So that means our tangent is pi over 4. And now, when we look at the options, A states 4 minus pi over 4, exactly where we're looking. So just in case, to make it simpler, 1 will be equal to 4 over 4 minus, because 4 over 4 is 1, I'm just switching it to make it same denominator. And it will be 4 minus pi over 4. And this is the choice of A, and A will be the answer for number 10. Like this kind of question, it'll be rare to have in real tests these days because this was from 1969. However, there's still possibility or chance you getting these hard problems for like a tiebreaker. So, when you look at this, like I said, even though you notice arctangent x squared plus 1 do not do anything and think, how can I make this to a familiar way or a solvable way? Think, oh, let's make it to 1 or at least 1 over x squared plus 1 or negative 1 over x squared plus 1, like this. So you can just plus 1 minus 1 because plus 1 minus 1 is 0, so it will then do not affect anything on the function because it's 0. And you can divide the function or the fraction like this to make it one and arctangent looking function. So if you get like these hard questions, before you jump right into the quotient rule or any kind of stuff, you should try to notice the equation and the function. Thank you for watching, and I hope this video was helpful.